In an earlier slide, I showed you this graphic right here and started off saying why are Earth and Venus so different. And we talked a lot about the greenhouse effect on Venus and why it went wild. And that had a lot to do with the atmosphere being different. The other thing is Venus has a little bit thicker crust than Earth does. That changes plate tectonics on Venus compared with Earth. That also alters the atmosphere and the climate and the land. Okay, so those factors also all play a role in here. The impact that created the moon undoubtedly made Earth with a thinner crust, which then led to Earth being more Earth-like. But other than that, there are some other things here. Venus is like a twin world physically. And it's almost the same size as Earth. It's got almost the same mass. It's got almost the same gravity as Earth. You know, the surface conditions are way different. The environment's way different. The atmosphere is different. But we talked about, you know, why Earth's atmosphere is the way it is. You know, Venus and Earth, you know, they are really close enough that if they were to exchange positions in space, they could have ended up being the other way around. In fact, if Earth gets warmer, you know, it is possible that we might look like Venus. In other words, as the sun gradually begins to get a little bit brighter, Earth may eventually heat up to the point that our oceans start evaporating, stop removing CO2 out, the greenhouse balance gets all screwed up, and we turn into Venus. Okay, so ironically, at the beginning of the 20th century, they mistakenly thought that Mars would be the first to be habitable, and then Earth, and then Venus, and they thought, you know, that Venus would be like Earth was millions of years ago, and Mars is like Earth is going to be in millions of years. It might be the other way around, actually. You know, so when we look at Venus, we may be looking at the future of Earth. Well, I also had this slide earlier. And in this slide earlier, I talked about how so this was an earlier lecture also, that as you go higher altitudes, the temperature drops, okay, and the pressure drops. The pressure is unbelievably high to the surface, and the temperature is unbelievably high. But as you get higher in altitude, at very high levels in the atmosphere, then what happens is the temperature actually becomes tolerable and the pressure is tolerable. Okay, so this is actually not that far off of Earth. Now, granted, the atmosphere is not nice still. You've still got sulfuric acid in the clouds along with nastier things. And so it's not nice at that altitude, but it is in fact much better. In fact, this is actually something they've toyed about with, is launching a spacecraft to Venus that has, you know, a balloon or something inflatable, so that it can actually just float in the atmosphere at those kind of levels up there and study it from the atmosphere. You need something that could tolerate the acid, but I mean, that is actually conceivable, that you could have a balloon flight or an atmospheric flight or an aircraft or something flying through the cloud layers. You know, just deal with the fact that you're flying through concentrated battery acid. Okay. But the interesting thing is, as I said, the surface is completely inhospitable, but at these altitudes, the temperature and pressure are much nicer. Now, that doesn't mean the environment is nice, because you have the acid and there's no ozone in the atmosphere to block ultraviolet light, so you have a lethal dose of UV light reaching those altitudes up there. And there's no magnetosphere blocking cosmic rays penetrating the atmosphere. So the radiation environment at those altitudes would be far more than the radiation environment at Earth's upper atmosphere. And so there are some things here that make it not particularly Earth-like. Okay. But the question is, life on Venus. We know there's no life on the moon. Okay, we presume there's no life on Mercury. Venus is like a twin world to Earth. Could there be life on Venus? I mean, this is one of the questions. Are we alone in the solar system? Well, first of all, the surface is too hot. No ifs, ands, or buts. The surface is too hot. Biological organisms, we always say, life as we know it. Well, even life we don't know it would have a tough time, surviving at those temperatures right there. I mean, it is pretty much inconceivable that life would live on the surface of Venus. That's just not likely. The cloud layers, on the other hand, are not too hot. And so it is possible that the temperature is right. And there are organisms on Earth that can live in concentrated sulfuric acid. Not very many, but there are a few. And so, it might be possible there, other than the whole radiation environment. The radiation environment is very, very inhospitable here. That's something not to be discounted. Now, this is something you may have heard about in the news, and that is just about a month or so before I'm recording this. I'm recording this in November of 2020. October of 2020, there was an announcement that astronomers had detected phosphine in the spectrum of Venus. So this is ground-based astronomers on Earth, and they were studying the spectrum of Venus, and they found phosphine. And now, why is that significant? Well, on Earth, phosphine is produced by anaerobic bacteria. Okay, by anaerobic life, archaea, for example. Not really bacteria, but anaerobic life produces phosphine. It's pH 3, so phosphorus, hydrogen, and 3 phosphorus and 3 hydrogen. So phosphine is produced on Earth. Now, it's also produced by non-biological means. But Earth is absolutely teeming with life. And so if you found phosphine variations on Earth, you would sort of be thinking, I wonder what kind of things are producing that. And you would think towards life. Okay, now, the astronomers found that on Venus, the amount of phosphine varied a little bit. And so now you can produce phosphine through non-biological means. You can produce it through volcanic activity and outgassing of rocks and so forth. But there was some speculation that there was so much of this being done that it might be produced by biologic activity. So this hit the news as possible life discovered on Venus. And it may be possible life on Venus. Not likely life living near the surface, possibly up in the clouds. Okay, but let's not forget that it is still very, very inhospitable. There's something in the sciences we call Occam's razor, and that is if you have multiple ways of explaining something, the simplest is normally the correct one. So it's possible that non-biologic means could have produced the phosphine that we see. If Venus is dominated by hotspot volcanoes, that produces more sulfur dioxide and phosphorus chemicals. That phosphorus could then mix with the sulfuric acid and possibly give you phosphine. Okay, or other sort of things. So it is possible that we could get phosphine through hotspot volcanoes, which may be dominant on Venus, not dominant on Earth. So the question is, does this finding say there's life? The answer is no, it doesn't. It's all the finding says is we found phosphine and variants of phosphine. One possible explanation could be biologic activity, in other words, life. The other possibility would be non-biologic activity. And Occam's razor says the simplest explanation would be, since we have never found any indication of life on Venus, and it is very inhospitable, even at places where the temperature and pressure are okay, you still have radiation problems, that trying to imagine some bizarre organism instead of some slightly unusual volcanic activity, that's probably a bit of a stretch. Now, that does not mean that there's no life, but it does mean this is not necessarily a detection of life. So that means more work needs to be done. But I just wanted to bring this out because this was in the news recently, and it is generally considered that the simpler explanation is more likely the correct one. And so that means while it could have been some sort of anaerobic life that produced the phosphine variations, it's more likely it was volcanic activity.